So one of the reasons I like this processor, there's a bunch of different reasons. It works well. There's other good processors, but one of the functions it has is you can tell it to either generate pink noise from its internal generator. Here it's just putting pink noise there.
Yep.
You can tell it to do narrowband pink noise, which is what you use for setting levels, where the bottom, the low frequency and the high frequency don't get in the way of the microphone. Or you can tell it to take any of the HDMI inputs, in this case I'm going to go to matrix, and use that as a signal that you then distribute around to any channel.
Gotcha.
So right now we got quiet because I haven't turned on the generator in Room EQ Wizard, and this is the little moment of truth where we're going to see if our connection actually worked. So we're going to go to noise, pink periodic, and there it is. So what we're actually hearing right now, I'll turn it back off. What we're actually hearing is the program, the actual application running on this laptop generating, in this case, pseudo-random pink noise. So rather than full random pink noise, it's actually 60, what do I got here? Sorry, 68,000 different frequencies playing in a sequence that looks like pink noise. That signal is coming out the HDMI port, going through that converter, through that extender, through that Cat6 cable you got from me. On the other side, it's converting back, going into the input that you labeled matrix, and we're hearing it come out there. And then when...
So you're actually generating that signal from your computer right here.
I'm hearing what's coming out there, which is super powerful, because then I can do all kinds of different really cool tests and stuff there. Then I can change to any channel, go all the way around the room, right? And with this one signal through the Storm's interface, I can go, okay, well, give me this signal over here. In this case, it's pink noise, but I can also do a single tone. I can do a sweep. I can do all kinds of different tests for intermodulation, different types of distortion and stuff. Thanks to this setup you gave me, and thanks to the fact that the Storm has that facility. And then, so most of the work I'm going to do is going to be through a combination of this periodic pink noise that I'm going to feed to the speaker, and I'm expecting a certain target curve. There's a certain thing it's supposed to look like. And I'm going to equalize the amps for that to do that. But I'll also do what's called impulse response measurements, where I'm feeding a very specific sweep of signal and establishing what it's doing in the time domain, which is also useful. And then all of the measurements are done. So these are omnidirectional test microphones. These particular ones are very good and not very expensive. You can get them for about $100. But before I use them, I test them against our very expensive Brüel & Kjær microphone, which is a Danish-made super high-end mic that they cost about between $600 and $1,000. It never leaves the lab. So that's our reference. We verify these mics against the test mic, go out on the road and just make once they're calibrated and working right, that's what we use. So I've got 4 of those. These particular models are just regular analog microphones. The analog XLR output goes through this cable and into the switch box where I can select between the 4 microphones. So that's the setup. There's other very complicated mic setups around these days that are interesting. I'm at the point where in the balance between the level of sophistication and simplicity where it works right all the time, I always try to ride this point where it's like, look, this is good enough that we're going to get the right result and not get into trouble. So that's the setup. So it's evolved a little bit from the days 20 years ago where it was all analog analyzers and stuff, but it's the same concept ultimately. Put pink noise into the speaker, measure what comes back, correct the errors.
There you go. And it's safe to assume that these are not the only microphone locations you're going to use. Or are you going to?
I am going to check different seat positions. So that's partly why there's that one microphone that I still have to hook up that's on a separate stand, because I'm going to check in the near field. I'm going to do a measurement at about 6 feet from the speaker, see what it's doing, and I'm going to verify other points in the room along the way. If there's a big difference as I'm moving around, then I'll move a mic over there. In most cases, just having a cluster like that at the main seat positions is good enough, but not always. So yeah, you definitely have to verify that.